Today I'm going to present my doctoral seminar work on agentic AI ops for root cause diagnosis in cloud environments. The broad area is AI ops, which means applying artificial intelligence to IT operations tasks such as monitoring incident diagnosis, remediation, and more specifically, I'm interested in agentic AI ops, where AI system does not only observe problem, but also reasons about them and can recommend or eventually trigger actions. So my focus is basically not to claim full autonomy immediately. So at least probably in later stages we can do that. But at this point, my work asks how can we take an existing conceptual framework, which we actually have published in literature, and turn this framework into an actionable model that can be implemented and evaluated. A little bit of background. So cloud systems generate large volumes of telemetry, logs, metrics, traces, alerts, deployment events, and service health signals. So it's a lot of data, as we can imagine. And when an incident happens, engineer must quickly understand what failed, why it failed, and what should be done next. This is difficult because the evidence often is distributed across many systems. And traditional AI ops helps with observability and prediction, but complex root cause diagnosis still often depends on human judgment. And I think this creates a practical research opportunity here. So basically, can LLM-based agent be structured so it diagnoses incidents in more disciplined, site reliability engineer-like way instead of just producing a generic explanation? And as I mentioned previously, so we have existing framework, and existing framework which was published by Zoda and colleagues. So it consists of three blocks: understand, decide, and take action, as you can see on the slide. Those are an abstractions for how an autonomous operation system should behave. So, for example, understand means collecting, interpreting operation signals such as alerts, logs, metrics. Decide means reasoning over evidence, and take action means applying, recommending remediation step. And in Zoda's paper, this is a conceptual framework for future agentic AI ops. So my framework uses an eventually probable model. We'll use it as a starting point, but then my work asks how to implement and test concrete version of it. So the problem I see is that current agentic AI ops work is often stays at the framework level. It describes what an agentic system should do, but it doesn't fully specify how to operationalize that framework into a testable implementation. And it's often not clear what makes one agent better than another, and what reasoning structure it follows, or how its behavior should be evaluated. So my research, I think, will address this by turning the framework into an actionable model with a concrete component, such as an orchestration, which we will look into these components in later slides. So components such as orchestrator, LM reasoning engine, tools for telemetry access, and skills layers that has encoded site reliability diagnostics reasoning. Okay. So if we if we're talking about problem statement, so let me discuss this. So existing, like as I mentioned, existing agentic AI framework are useful because they define what future autonomous operation systems should be able to do. But however, these frameworks remain mostly high level. They do not fully show those ideas can be how those ideas can be turned into actionable and testable root cause diagnosis model. So my strategy is this, and first I implement concrete model. Let me go to that model. This is basically the design of the model I implemented in Azure, which is actually just the beginning. And in my model, an observability alert, as you see in red here, very top, enters event router and passes to an agent orchestrator. An orchestrator coordinates the LLM skills and tools. The tools are the agent's connection to operational context, for example, querying logs, retrieving metrics, checking deployment history, etc. While skill layer is for the agent, it gives agent a diagnostic method. Basically, it instructs what agent should do. So what to check first, how to correlate evidence, and when to rule out alternative causes. So, and as when I implemented it, I basically came up with two agents. So my proof of concept project compares two agents. Both agents are hosted in Azure Foundry. Both receive the same incident alert, and both have access to the same data, logs, metrics, and deployment history. The difference is in the instructions design and tools layers. The baseline receives a general instruction to diagnose the incident and return structured output. The skilled agent receive site reliability engineer operating protocol that defines diagnostic properties, tool sequencing, evidence correlation, alternative cost checking. So the goal here is to observe whether the skilled agent produces better diagnostic output across the same scenarios. And evaluation. So how do we compare these two agents, agentic AI ops models? So the evaluation compares the baseline and skilled agent and across three incident scenarios. At least it is for now. It might be expanded, and likely it's going to be expanded if I'll stick to this topic. So for now, it is just deployment regression, resource exhaustion, and dependency failure. And each scenario has fixed telemetry and known ground truth root cause. Agents return a root cause hypothesis, mitigation step, and tool called trace. And I evaluate both the final answer and process used to reach it. The metrics include intent resolution, task adherence, equivalence to ground truths, and tool call accuracy. So to conclude, so by doing this research, by doing this paper, I'm planning to contribute. I'm planning to do three contributions here. So the first one, it takes the high-level agentic IOPS framework and turns it into an actionable root cause diagnosis model that can be implemented and evaluated. Second is I enrich that model with skill and tools layers. So this model is not only generating diagnosis, but also supported by operational guidance and access to relevant evidence. And third, it compares the enriched model with baseline model, as that doesn't include layers such as skills and tools layers, using the same incident scenarios. And together, these contributions move the work from a conceptual agentic AI ops framework to our testable model for cloud diagnosis. Yeah, that's basically it. Yeah, so questions are welcome.
Hi, Albert. That's a nice presentation, and it's very helpful. I just want to ask a single question. You said the existing multiple ops agents. What the difference did you observe in the performance or the metrics? What's the main difference that you observe by using this one, which you present, or the previous existing models?
Previous the model I'm taking as a base, as a foundation for my work. They this model wasn't tested at all. It's just that work stays at the framework level. Basically, after just share vision, how they see the agentic AI ops should look like. And my uh, sorry, please, sorry, I didn't hear well.
No, no, no. You're good. I'm not speaking. It's just
Okay.
yeah, yeah.
Yeah, so and what I'm trying to do, I'm trying to operationalize it, move from theory to practice, and not only just implement, but also have basically two agents there. The one which doesn't have any, it has basic information about the error, which normally could be extracted from the logs from different systems. Another agent is more skilled agent, so-called skilled agent. It will have a particular set of instructions, what to do, where to look logs, what information, if some information is needed, where to get that information. All this type of instructions are going to be set for the second agent. And the so not only I'm going to implement it, but also compare how within this model two different agents look like, behave, what's better. Because it is tempting to think that if agent has a lot of skills, a lot of tools, it could behave better, which is reasonable, but we should prove that if that's true, I think.
Yeah, that answers my question. And I just want to know, I saw in the architecture diagram, I just saw a knowledge base. Is that the knowledge base for your agentic ops that you're using? Um,
So for the
uh,
data,
yeah,
currently,
yeah,
currently what I did is I use synthetic data here, and no knowledge base was implemented. But for the when it comes to real data, yes, I have extensive knowledge base. Actually, I have access to. The only question is, will I be allowed to use that in a real research? I'm not sure, but yeah, I work on that. So the idea is to have it. Yes, ideally we should have it either with Elasticsearch or somehow we should access it. I don't know yet, but yeah, that's a good direction to look at.
yeah, yeah. Thank you for answering my questions, Albert. Yeah. If anyone or have some questions, you are all welcome.
Thank you, Albert. Very good presentation and very interesting topic. Um, Even though I was not able to fully listen to this one, I was between sessions. So what has been the biggest obstacle for your study so far?
Uh, to get to real data, I have access. I literally have access means I can see them in a computer, right, from my working laptop, whatever. But I can't take them out. That's the biggest obstacle. So if I had real data in place, I would probably get more uh, accurate results, and you know that's the biggest obstacle. And I'm working on that. Hopefully, yeah, get this solved soon.
Yeah.
Thank you.
And I should also say I should also give credits to Dr. Dooley, who actually helped here a lot. Dr. Dooley helped to bridge the gap between so I'm practical guy. I work a lot with cloud and everything. But the always problem I have is to bridge the gap between practice and theory and science actually. And this is where Dr. Dooley helped a lot. And yeah, I want to thank Dr. Dooley.
Excellent. Yeah, thank you. Yeah. So I look forward to your progress.
Hopefully, yeah.
Thank you.
I'm gonna stop my presentation.
Iridar, would you conclude the session?
Is Amanda not going to come? I just want to know.
I think
I
so.
haven't read the chat.
Right.
Uh,
Yeah. Mhm.
uh,
I just want to say thank you to all the DIT students who presented today. Um, this was really this is really great to see your progress and the very interesting topic you shared. And let's keep doing those. Let's keep working on this so that we can get feedback and improve the quality, and and produce the outcome that you'll be proud of. So thank you very much.
uh, even I want to thank everybody who presented today. And this was very knowledgeful, and I was glad to see all of you work so hard to present this, um, to complete these projects. Thank you.
Thank you.